Okay, let's start the class. Uh, Before CA1, I have already discussed these things, no, but not in the PPT, but I have provided the notes, no. So let's start with this. I think all of you have received the notes. I have sent you before CA1 exam, and some of the questions were there from these notes also, but I have not discussed yet in the class. Okay. So actually from this the main technical conceptualization of Pi foundation and the numerical parts of Pi foundation is started. That is the load bearing capacity of Pi. Now before going to the load bearing capacity of Pi, I think you should remember the load bearing capacity of footing, that is the shallow foundation. That is that you have studied in previous semester in soil mechanics 2. The last module was the bearing capacity and settlement of shallow foundation or footing. No. So can you remember what is the bearing capacity of shallow foundation? How that thing bearing capacity of shallow foundation you have determined? What is the formula? What is the equation and concept? What is the theory?
Using Target theory.
Yes, you are correct. That is the Target theory. Target's theory is used to find out the bearing capacity of shallow foundation. No. So in that case, what you have done? In the bearing capacity of shallow foundation, what you have done? What is the equation or formula of Target's theorem? There are that some prerequisite thing of Target's formula, and there are some assumptions of Target's formula. Those are theoretical parts. I am not going to that. But what is the main equation or formula of Target's theorem? Anyone? These I think you should have that idea because you have already studied in this in the previous semester and you have completed your semester exam of soil mechanics 2. That is ultimate bearing capacity is equals to CNC plus, yes, correct, CNC plus
Gamma dF into NQ.
yes, that is gamma
Gamma into dF.
gamma dA plus half B
Gamma.
n gamma. Okay, so that was the bearing capacity of shallow foundation. But why I am discussing that part here? Because in case of Pi foundation, there are two mechanisms. Those are simultaneously work. Those that you can see that one is the end bearing mechanism, another is the friction mechanism. Okay, these two mechanisms work simultaneously to carry the superstructural load that is coming from the building or structure or anything structural components. Okay, so these two mechanisms, from that this end bearing thing is not much different from the shallow foundation. That's why I am discussing that shallow foundation thing here. Okay, so what is the thing end bearing and what is the friction mechanism to bear or to carry the superstructural load to the foundation? That we have to understand. Okay, before that you can see from this slide that load that can be carried or that can come from the superstructure to the foundation, and through the foundation that load will go to the soil. This is the main hierarchy of the load carrying through the foundation. Superstructure load, total load from the superstructure will come to the foundation, maybe shallow foundation, maybe deep foundation, and through the foundation that load will transfer to the soil layers. Okay, so the foundation is the mediator from the superstructure to the soil. So in this case of pile foundation, there are two mechanisms. One is the end bearing, another is the friction. Okay, according to the mechanism of load carrying, we can separate out or classify pile into two classes. Before that, we have classified piles according to the material and the method of construction. No, we have classified already. We have studied the classification of piles according to the material of which that pile is made of, and another one is the method of construction. Okay, and these two classes, or that is the end bearing pile and friction pile, these types are according to the load bearing mechanism. Now why we didn't discuss this classification in that part of classification of pile? Because we can theoretically classify this thing, this end bearing pile and friction pile. Theoretically you can classify, but there is practically that is not possible for any pile to carry the load either of these two mechanisms. That means in each and every cases of the pile foundation, these two mechanisms will work simultaneously. Is that clear? That means maybe 1 or 0.1% of the load will be carried by end bearing, and 99.9% load is carried by the friction mechanism, or vice versa. That is 1% of the load is carried by the friction mechanism and 99% of the load is carried by the end bearing mechanism. But there will be a slight percentage of load must be there that will be carried by either of these mechanisms. Is that clear? Okay, that's why solely end bearing pile or solely friction pile, that cannot be possible in the practical case. But theoretically we can classify end bearing piles, those piles which are actually carried the load by the end bearing mechanism. That is, the end bearing means by the end, that is the tip of the pile. Tip of the pile means if we see the top view of a pile, that is maybe a circular, maybe a square. These are top view, and maybe the bottom view also. In practical cases, this bottom radius or bottom diameter of pile will be lesser than the top diameter of pile. That's why the bottom point is called the tip of the pile. Okay, so by this area, if the diameter is maybe d, by this area of pile, some amount of the load, some percentage of the load will be carried. That means this is the similar case of shallow foundation, because shallow foundation may be circular foundation or maybe square foundation or maybe rectangular foundation. Shallow foundation, I am talking about footing. The area, bottom area of the shallow foundation is the solely region or sole parameter which carry the load through the shallow foundation or footing. Is that okay now? Because there is no friction type of thing, or no shaft, or no length of the footing. Is there any length or friction mechanism in the shallow foundation? No. Only the area of the shallow foundation, that is maybe rectangular footing or square footing or circular footing, the bottom area of the shallow foundation will take care of the total load. So in this case of pile, that pile tip, bottom area of the pile will take care of some amount of the load. So this is the similar mechanism of the shallow foundation or footing. Then what is the friction mechanism? That is coming from the surface area of the shaft. That means in the previous classes I have told you pile is nothing but a slender member, that is maybe 10 feet, 20 feet, 30 feet of length, generally circular. Sometimes we can if steel pile we are using, then I have told you that channel section, hollow channel section, H section, H means I section, or angle section we can use. In that case, those are not circular only, that steel piles, but concrete pile or timber piles, those are almost circular in the cross section. Okay, so if a slender member of a length maybe H and diameter tip and top diameter is D maybe, then I think we can calculate the surface area of the slender material or the this curved surface, only the curved surface, not this or this, only the curved surface, that is called shaft of the pipe. Okay, is that okay? What is shaft? Shaft is the curved surface area of the pipe. Okay, so can we calculate that curved area? Anyone? What is the area of that curved surface? How can you calculate? If the height is H and diameter is D, then this is D, this is the same. We are considering the same diameter at the top and at the bottom. What is the shape is this? Huh? Hi. What is this 3D shape? Yes? Cylindrical, yes, cylindrical. So what is the surface area of cylinder if H and D is given?
Pi d square H.
Pi d square H. What is the difficulty? Pi d square H is the area of the pile shaft. Simple. This is coming from the basics of mathematics, nothing else. Okay. So pile shaft area, if we can calculate, then there are some theories and formulas and equations. From that we can calculate the load bearing capacity of pile. And in this case also, ultimate load bearing and safe load bearing, similar to the shallow foundation, we can calculate. Okay. So coming to the next, that is the load transfer mechanism of pipe. This note is also I have sent you earlier. Okay, so this is the load transfer mechanism in pile. I have already told you that friction mechanism and end bearing mechanisms. End bearing is sum of, if this is the pile, so sum of the load is carried by this area, this circular area, and sum of the load is carried by this area, this area. Okay, this total area. Okay, so end, that means we are standing somewhere in the floor. That means our leg is carrying some load of our body, but we don't have that friction mechanism. If we can stand inside some soil and that soil cannot carry our total weight, then we have to go for the friction option. No, similar thing. Okay, so the friction capacity and end bearing capacity, this total summation will be the total bearing capacity of pipe, friction capacity and end bearing capacity. Now ultimate load bearing capacity QU is this skin friction capacity and end bearing capacity. If applied load increases beyond the total, that means the ultimate load bearing capacity, then that pile will fail due to the applied load. Now when Q is applied on the pile top, okay, let's go to the next slide. Yes, if Q load is applied at the pile top, okay, then if we assume this Q is a very small load compared to the ultimate load bearing capacity of pile, then this total load will be carried by friction capacity of this pile. Okay, now if we increase this load from Q1, some notation. Okay, if maybe the ultimate load bearing capacity is 100 kilonewton for this pile, if we can start from 10 or 5 kilonewton load at the top of the pile, then that load will be solely carried by the friction capacity of the pile. And these lines are actually for the conceptualization how this load is carried by the friction capacity and end bearing capacity. Okay, so sum of the load is carried by the friction capacity, and if this Q load is increased by some value, then also some that load is carried by only by the friction capacity, and by that if we reach to some load, at that point the total friction capacity will be utilized. That means after that if we increase the load, then some of the end bearing capacity will be utilized. Is that clear? That means let's say skin friction capacity of this pile is 60 kilonewton, maybe as an example, 60 kilonewton, and this Q2 is 60 kilonewton. Then total skin friction capacity of this pile will be utilized, and if we then again increase this Q load to maybe 65 kilonewton, then 5 kilonewton of the end bearing capacity will be utilized. And again if we increase that load from 65 kilonewton to maybe 70 kilonewton, 75 kilonewton, 80 kilonewton, then total skin friction plus sum of the end bearing capacity will be continuing to utilize. And when this Q will be QM, that is as our example 100 kilonewton, that is the maximum load. Okay, when we reach to the 100 kilonewton load, then total friction capacity of this pile and total end bearing capacity of this pile will be utilized, and that is the maximum load that this pile can carry, or with that this pile can stand. And if we increase from this QM, or for our example 100 kilonewton load, then that pile will fail due to the extra load. That means maybe 110 kilonewton load, then this pile will fail for that extra 10 kilonewton load. Is that clear? What is the mechanism of load carrying or load bearing in a pile? And this is the difference between the shallow foundation and deep foundation. In the shallow foundation, only the end bearing mechanism will act, because there is no shaft type of thing, no friction kind of thing, and that's why no friction capacity. In this case of pile, there is a slender member as pile and the total surface area of the pile is much higher than the tip area or the bottom area of the pile. In this, what is this area? If diameter is the pi square, that means pi by 4 d square. Okay, this area is pi by 4 d square. Generally, pi is noted for its diameter. Okay, and this you have already told you what is the surface area, the part surface area, shaft area.
Pi d square.
What?
Pi d square.
Only pi d square.
Pi d square.
No, not pi d square h. This perimeter, what is this perimeter?
2 pi.
2 pi r, that means pi d and h. This is the shaft area. Because if you unfold the total thing, that will be a rectangle. One side is this 2 pi r or pi d and another side is h. So if you unfold this total thing, that will be simple a rectangle, and that area of the rectangle is the shaft area, that is the pi dh. Okay, so this pi dh is much higher than this pi by 4 d square, isn't it? Because maybe at 20 feet of pipe, you can calculate. If this diameter is maybe 2 or 3 feet, then you can calculate. If this is 2 feet, then only pi. Pi means 3 point something, 3.14 meter square. Sorry, feet square. And this pi d means 2 square, that is 4 pi multiplied by 20 feet square. How much? That is much higher than this value. No, that means friction capacity is very much important in case of pipe, but that friction capacity is not there in the footing or the shallow foundation. This is the difference between shallow foundation and deep foundation mathematically. Okay. It will be there. Okay. Okay. So in the slides, similar things are written. You can read that or you may note that. I have already sent the notes. Okay. Now coming to the main part of the pipe foundation, single pipe foundation. There are two parts in this module. One is the single pipe, another is the group pipe. Okay. So in your course outcomes, I think you have the syllabus already sent, and in the course outcomes CO things, you can find out that there are two COs in this single module of module 2. Okay, one is for the single pipe, another is for the group pipe. Okay, now again, what is the difference between the single and in the group? Single pipe cannot possible in the practical scenario site. Single pipe, that is only for theory, only for conceptualization, only for understanding the numerical thing, numerical parts, mathematical parts, for that. Okay, because in a structure or in a building, single pipe cannot act, that means according to the load that is coming from the structure or according to the shape of the structure. Single pipe cannot be there in any of the structure practically. But under any of the structure, that may be a flyover, maybe a high-rise building, maybe anything, under a mat foundation also, there will be group. A group of a number of piles will be there. So pile group is the practical thing. Single pile is the theoretical thing, but single pile you have to understand before going to the pile group, because the main conceptualization, mathematical understanding, that will be there for the single pile. Okay, and some modifications are there for the pile group. When we are going to the pile group, some modifications, some coefficient type of thing we have to add to the conceptualization of the group pile, nothing else. Is that okay? So starting from the single pile, that is the determination of the ultimate load bearing capacity for a single pile, and there are two process, two methodology to determine the load bearing capacity. Two methodology means here you can see this is by static formula, and another kind of methodology that will be dynamic formula. Okay, dynamic formula notes I have not sent yet, I think. Okay, those notes I will send before the next classes. Okay, so this static formula is according to the IS codes, Indian Standard Codes. And what is the code for pile foundation design? Do you know? IS. Okay, let's show you. You may have this code from the internet also. I will provide the main that important page from where you can able to do the design of the pile. That page I will provide you, but you can download the full PDF file of the code from internet, and that code is yes, 2911. And what you are saying? कौन बोला? Hello, बोलो. What is the IS code of?
IS 2911 part.
Yes, IS 2911.
2010.
These notes I have already provided you. That is the IS 2911 part 1 of section 3. 2010 is the modified or updated version. Okay, and this page you can see the page number 14. Page number 14 of the code, and in your exam you have to refer this page and this code when you have to design the pile. Okay, all these prescribed things you have to refer when you are going to design any pile foundation. Is that okay? That is IS 2911 part 1 section 3 of the year of 2010, page number 14. Total thing you have to refer, and this is for granular soil, that is the cohesionless soil. Okay, another part is there. Yes, another part is there, that is the cohesive soil, and the page number is 15. Same code, same, that is IS 2911 part 1 section 3 2010, but in the next page of page number 15 you can have the prescribed formulas and parameters in this page. Okay, so total reference you have to give when you are going to design a pile foundation in your exam, in your projects, or any other thing. Okay, is that clear? Okay, so let again go to the slide. Okay, so this is the ultimate bearing capacity of pile foundation by static formula, and already you know there are two parts, that is the skin friction and base load or end bearing capacity. Now this is the base load or point load or end bearing capacity, that is QB, and QF is the skin friction capacity. Okay, these two, summation of these two will be the ultimate load bearing capacity. Okay, and this QB is the small QB multiplied by B. Now this is the main part of this formula. What is QB? QB is the base load or point load or end bearing capacity. That is the capital QB. In the next part of the equation there is small QB. Small QB is nothing but the bearing capacity that is coming from the Tate-Jaggi's formula in the shallow foundation. Okay, and this AB, capital AB is the area of the circular part. That is the in this case pi by 4 d square that you have already calculated. That area is AB. That means from the notation, this is the this is AB. Is that okay? And AS is this part. This is the AS, area of the shaft. Okay, that AS is coming with the skin friction part, and FS is the ultimate unit skin friction, and this ultimate unit skin friction let's see in the code. Okay, this ultimate unit skin friction, okay, not this one, the previous one, that is this. This is the questionless one, no? Yes. Yes, this part. Okay, this skin friction is coming from this. That is, can you remember the triaxial case of soil element in the shear strength of soil? What was that? Okay. Don't be worried. That is, if this, what is sigma h, what is k gamma h, I think that you can remember. क्या था ये? No. What is total thing? This thing is coming from lateral pressure, lateral arc pressure. Have you all forgotten? Lateral pressure thing. K is, you are saying something. K is coefficient of lateral arc pressure. Lateral arc pressure, not the arc pressure. Lateral arc pressure. Gamma is the unit weight and h is the height. Okay. So this K gamma h, or you have studied that as K gamma h or Kp gamma h. The formula is K gamma h and Kp gamma h in the lateral arc pressure theory. That is the Rankine's arc pressure theory. Have you all forgotten those concept of arc pressure? That was the first module of the soil mechanics 2. No. So this gamma h is the K gamma h. Sigma h is the K gamma h. That is the lateral pressure. This is the coefficient of lateral arc pressure. Okay, and this K gamma h, if this is the lateral arc pressure, please understand carefully. This is the lateral arc pressure. Okay, this is the curved area or any kind of area. Let's go to the concept of friction. Concept of friction. What is the concept of friction? Frictional, total frictional force Can you remember from the physics? Friction force. Yes. Please be confident. You are answering correctly, but you don't have the confidence. That is mu multiplied by r. What is r? Please speak loudly. Who is answering? Please speak loudly. You are correct. You know all the things, but you don't have that much of confidence. Nothing else. What is r? No. That is wrong. Not the resultant force. This is the normal reaction, and this normal reaction is coming from. This is coming from the reaction of the weight of the object. That is, let's go to the concept of friction. If this is a body of maybe weight W equals to mg, nothing else. Mass multiplied by acceleration due to gravity. Then due to this weight is a force. No, this weight is a force na? Weight is a one type of force. So if this force is acting from this object to this floor, to this subject, surface, to this surface, this weight is acting from this object to this surface. Then according to the third law of Newton, the surface will apply a force that is equal and opposite to this weight. That is the normal reaction, and that is equals to W. Is that okay? Now frictional force, that is if this object is tending to move in this direction, then frictional force will act at this direction opposite to the movement, at where? In the connection between the object and the surface. Now coming to the pipe, why this physics is so important? This is